In the last lecture, we talked about how to determine protons, electrons, and neutrons using the periodic table and using the atomic number and the atomic mass of an element. What we're going to talk about now is we're going to talk about different versions of an element. So when you look at the periodic table, everything on there is what's considered to be neutral. It doesn't have a charge. And what that means is it's unstable. In order for something to become stable, it needs to either gain or lose electrons to fill those shells. So what happens in nature is most things are ions, and they either lost or gained electrons, and they have a charge, either positive or negative. So what we're going to talk about today is how do we determine protons, electrons, and neutrons for an ion. So let's get started. So what is an ion? Well, basically all an ion is a charged particle, which means it has a positive or a negative charge on it. And if it has a positive or negative charge, that means it will either attract or repel from other elements. And what causes them to have that change in charge is the number of electrons. Now, you might remember me saying this a couple times. I'm going to say it a couple more. The number of protons of an element can never change, because if the number of protons change, that means it's a new element. So it's no longer carbon, it's nitrogen if it gains a proton. So the way we get ions is an element can gain or lose electrons. So a proton, the number of protons for an element can never change. So what ends up happening is if we have a positive ion, that means there's more protons than electrons. And if we have a negative ion, that means there's more electrons than protons. It's as simple as that, either gaining or losing electrons. So we're going to talk a little bit more about that now. Let's do an example. For example, sodium with a +2 charge, how many protons and how many electrons does it have? Well, let's try it out and see what we get. So let's go back to our example over here. And what we have is we have sodium, right? Na. It's got an atomic number of 11 and an atomic mass of 22.99, which we're going to round up to 23. So let's just go with not an ion. If it's just in this state, it's going to be protons, electrons, and neutrons. So the atomic number is 11. So we know there's 11 protons. So let's go with 11 pluses. It's 11 pluses, right? And with no charge on it, we know that there's going to be 11 electrons, right? Well, those are a little closer together, but there's 11 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then our number of neutrons is going to be atomic mass, which is 23. Subtract the atomic number, which is 11, and that gets us 12, right? So now what I wanted to know, though, is what if this has a charge on it, right? So what if this sodium has a -2 charge? So let's put a little -2 there. What that means now is there's more electrons than protons, and that means it's going to have actually 2 more electrons than protons because it's got a -2 charge. So how would I change this number? Well, if you take a look here, I know they don't exactly line up, but there's equal numbers of negatives and positives. So I would just add 2 more negatives. So how many electrons would I have? I would have 13. Now, I can't change the number of protons, so it's not like I could take away 2 protons. That number has to stay the same. So imagine, I like to imagine a lock around this. So like imagine this is a lock, like a padlock. This number cannot change. I know it doesn't look much like it, but that's a padlock in my head. I'll put a little keyhole here so you can see it's a padlock. It's a keyhole if it makes. Okay, so that number can't change. Only this number can change. Now, do the neutrons get affected? The answer to that question is a big resounding no. And the reason why is because neutrons are neutral. They don't have a charge. So if this could be a minus or plus 100, and the number of neutrons is not going to change. Let me give you another example. Let's say now, instead of it being, let me just erase this here. And instead of it being a -2 charge, now it is a +2 charge, right? So now it's got a +2 charge instead of a -2 charge. So originally there was 11, so I'm going to draw my 11 back. I shouldn't have erased those. Right? So now I have a +2 charge. I want to add 2 protons to make it more positive, but I can't, right? I can't change the number of protons. So if I want to make there be 2 more positives than negatives, what's my only option? My only option is to take away 2 electrons. So if I take away 2 electrons, now I have 2 more positives than negatives. So it's got a +2 charge. So how many electrons do I have? I would have 9 electrons. So again, the number of neutrons does not change. The way you change the charge on an atom is you either add or take away electrons. You can never, 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 right? That's angry. Never, never change the number of protons. You can only ever change the number of electrons. Okay, we have one more thing to talk about, and then we will be done with this lecture. And we have to talk about isotopes. Now, isotopes are going to involve neutrons. So here's the thing about the periodic table. If you look at any of the masses on the periodic table, like for example, carbon is 12, right? Every single carbon, there's different forms of carbon, right? There's actually 3 different forms of carbon. And it's that 12 is the average mass of carbon. So there's a carbon that has a little heavier, and there's a carbon that's a little bit lighter. So different forms of the element are going to change based on the number of neutrons. So let's do an example here. The way you would write out an element with its mass is you would write the, let me just use my pointer here. You would use the carbon and then followed by the atomic mass. So this is carbon 12, this is carbon 13, and this is carbon 14. So let's take a look at this example using our carbon example. So carbon has an atomic number of 6, atomic mass of 12, right? Now, what I have written here, though, is I have carbon 12, carbon 13, and carbon 14. So just to remind you again, that dash and that number tells you it's got a different mass. So most carbon is carbon 12, and that is why it's 12 on here. So if I were to take all the carbon that exists in the universe, most of that carbon, by a huge percentage, is carbon 12. But there are some that are carbon 13 and carbon 14. So what does that actually mean? So let's take a look here. Well, the number of protons is always equal to the atomic number. That never changes. So that's 6. We know that. Is there any charge on this? Is there a positive or negative over here? The answer to that question is no. So we know that the electrons and the protons are equal. So that is also 6. And then my atomic mass is going to be 12 minus 6, which would be 6. So it would be 6, 6, and a 6 for carbon 12. Well, now let's look at the 2 isotopes of carbon. Carbon 13, it's still, protons never change, so that's not going to be any different. There's still no charge on it, so that's not going to be any different. That's also going to be 6. So the only difference here is now instead of it being 12, the atomic mass is 13. So 13 minus 6 is actually going to be 7. Okay, so now there's 7 neutrons in carbon 13. And then finally, in carbon 14, it's going to have the same scenario. The protons always equal to the atomic number. There is no charge on it still, so that's going to be 6. And then finally, our atomic mass now is 14. So 14 minus 6 is going to be 8. So the only thing that changes in an isotope is the number of neutrons. These get bigger. Now remember, isotopes don't act any different because there's no charge on neurons. So what that means is they don't affect how the atom actually works. What determines how the atom works is how many protons it has, and more specifically, how many electrons it has. So just to kind of finish up here, we have isotopes are different forms of the same element. If I gain weight, I'm still me, right? If I gain 10 pounds tomorrow, I still am going to have all the same characteristics I have. I'm just a little bit heavier. So that's essentially what an isotope is. It's a heavier or lighter version of an element. And an ion, on the other hand, is a charged particle, which means it either gained or lost electrons, but the protons will never change, and the neutrons aren't affected either because the neutrons don't have a charge. Thank you very much.